Hi everyone, welcome to my channel. I hope you are doing well. So today in this video, we will learn about Kubernetes. So we will learn why do we need Kubernetes, what is Kubernetes, its architecture, its core components, and we will try to understand the flow of Kubernetes with a small example. But before moving ahead, I would like to say if you are not very comfortable with containers and Dockers, so you must watch one of my video on Dockers and then you must watch this video. So let us get started. First thing first, why do we need Kubernetes? So as we know, the containers have become the fundamental part of any modern software development and deployment. So they are everywhere. And we also know Docker is one of the most popular platform to manage the containerized applications. So why do we need Kubernetes if Docker is there? Why do we need it? So let us try to understand with the help of a very simple example or real world example. Amazon.com. Everybody uses Amazon.com. Amazon.com complex structure has been divided into multiple microservices. We have different microservices like payment services there, card services there, user management services there, inventory services there, recommendation services there, catalog services there. A lot of services are there. Since we know there are many services are there, and what we want to do is we want to build an environment where we could automate everything in the form of containerization. But few features and few needs we have. So what we want is automated deployment should be there, since we have hundreds of services, and in each of the service there could be 100 or 1000 instances of that particular service could be there, because it's a very popular website, traffic coming from all over the world. So the need of scalability in terms of scaling up, scaling down should be automatic. There should be a straightway provision for auto healing. If one of my service goes down or if one of my worker goes down, there should be a way to automate that process. There would be a different resourcing need based on service to service. Some services may need high-end machines, some services may need less compute power. So that also should be there. And moreover, there should be a provision when someone has to upgrade a particular feature in one of the service, then it should give that flexibility that there shouldn't be any downtime. And there are other more complexities are there when it comes to managing a complex environment with multiple services with different scaling needs and resourcing need. This is where Kubernetes plays an important role and it has ruled the market. Now, what is Kubernetes? Kubernetes is an open source container orchestration platform which is designed to automate the deployment, scaling, operational and management aspects of the containerized application. It is also known as K8s. So K8s is nothing but the 8 characters between K and S of Kubernetes word. It was originally developed by Google and the project name was BOG. Right now it is being maintained by CNCF. So let us try to understand the architecture of Kubernetes with the help of this diagram. As we could see in this diagram, so we have master node and we have different worker nodes. It follows the master slave architecture or master worker architectures. Like a typical master slave architecture, master node is responsible for taking all the decisions. It assigns different tasks to different workers and making sure the cluster or a system is working fine. So it helps in managing overall operation of the system. Worker node actually gets instruction from master and then they execute the task. So actual work is happening on these different worker nodes. Now let us try to understand that the working of a worker node first and then its core component. There would be multiple worker nodes in a typical cluster. And each of the worker node, we know they are the actual node where the execution would be happening. So in our case, the actual container would be running on these worker nodes. Now, let us try to understand the pod. So pod is the simplest and smallest deployable unit in the platform. You could think if we have to run any container application, that would be a part of pod. So pod is a single instance of that particular process or a particular application running in that cluster. It may happen that in one pod we could have multiple containers, but as a best practice, it is recommended that there should be one pod per container. Now to run these containers, so we need a runtime environment. on each of the worker node, we need this container runtime environment. So we need to install Docker or similar container platform tools. Only then we'll be able to run these applications. Next comes kubelet. Kubelet is a primary node agent of the worker node, which interacts with both node and the container in the worker node. So this is responsible for maintaining a set of pods which are composed of one or more containers on a local system. And it is also responsible for registering a node with Kubernetes cluster, sending events, pod status, and reporting resource utilization. So basically, kubelets interacts with the master node API server. It gets instruction from API server in the form of pod specification, which we write in the form of YML or JSON object, where we have all the description about the pod and all its details. So on that basis, it has a responsibility to bring up the pod, ensure that pod is running, and it will keep on sending the information back to API server. Now let's move to the new component, which is kubeproxy. Kubeproxy is a network proxy that runs on each node in your cluster, implementing part of the Kubernetes service and concepts. It facilitates network communication between pods and services. So far, we have seen that these three processes need to be installed and running successfully within your worker nodes in order to manage your containerized application efficiently. But the bigger question is, who manages these worker nodes? That they are always up and running. How Kubernetes cluster will know which pod should be scheduled, where and which one should be dropped or restarted? How does the Kubernetes cluster know the resource level requirement of each container app? Well, the answer lies in the concept of master node. Let us try to understand the master node. So master node is also known as a control plane. It is responsible for managing worker nodes efficiently, and they interact with worker nodes for scheduling the pods, monitoring the worker nodes, monitoring the pods, starting the pods, restarting the pods, and other things also. Like worker node, master node also have couple of processes that keeps on running at the backend. So each of the master node in Kubernetes cluster, the following processes runs like API server, scheduler, a control manager, and etcd. Let us try to understand each of the component in detail. Let's start with API server. So basically, it's a main gateway to access the Kubernetes cluster, and it acts as a main gatekeeper for client level authentication, or we can say that it's a front end of the Kubernetes control plane. You want to deploy any new app, schedule any pod, create any new service, or query status or health of your worker nodes. So you need to make a request to this API server of the master node, which in turn will validate your request before you get access to the processing in worker nodes. Let's talk about scheduler. So now if you want to schedule a new pod on the worker node, so you will place a request to API server, which internally will call a scheduler. So this is an entity which would decide on which worker node a pod should be running. So this is a key control plane component that keeps a watch for newly created pods with no assigned worker node and selects a worker node for them to be scheduled and run on. So before choosing like where it has to place a particular pod, scheduler takes certain consideration before doing so. So basically, let's say it first check, this particular pod needs this much resources. So it will check which particular node having this many resources are available. And then it will also check, is there any constraint in terms of some software level or hardware policy level which has been enforced. So taking like certain consideration, it will decide that on which node that particular pod should be scheduled. So next is control manager. So it's one of the critical process in a master node that monitors the status of any worker node level failures. It keeps a close watch over the events like crashing of any pod in the worker node. It requests the scheduler to restart or reschedule any dead failed pods after detecting such events. So these control managers have certain different types of controller as well, like node controller, replication controller, and then we have other controllers like endpoint controllers, service account, and token account controller. So we'll discuss these components in detail in future videos, but at high level, this is a core component. Now next comes the etcd. This is responsible to store every kind of cluster level change in the form of key value pair. It can be easily seen as a brain of the Kubernetes cluster, which keeps the log of every minute detail of changes occurring in the cluster. For example, let's say any pod crashes on any worker node and that has to be rescheduled. So the same entry would get stored in etcd, and then Also, when the pod would be scheduled on some node, that entry will also be there. Basically, the data that etcd keeps it really helps us in maintaining the different health check in terms of what kind of resources are available on the node. Did the cluster state change due to any node failure, or is the cluster health okay? So all this information is actually stored in distributed key value store, so that the proper decision and proper functioning could be done. Since we already have a fair understanding of worker nodes and master node and their different components, what exactly they are doing, now let us try to understand the working of this complete architecture with the help of a very simple example. It's a very basic application. What we are doing is we are creating one nginx server, which is a web server used for reverse proxy, load balance, and other things. As we have already discussed, pod takes input in the form of YML or JSON. So we are using the YML. In this, we are specifying like very basic thing like what is the ABF version, since we are creating a pod, the name, and from where we have to pick the base image and the name of the container. Once we have defined this YML, we will save the YML and then we will run this command kubectl, which is a kind of a CLI interface. By using this, once we will apply this thing, a container will come up. Since we know that we have created a very simple example where we are bringing up the nginx server, so user will interact with API server. API server will first check user request is valid or not, it is well authenticated or not, and then it will save that information in etcd. And then the scheduler, which is listening on these events, it will see, okay, the new pod request has come. Then using his scheduling policies in terms of resources requirement or other things, it will get that information that where this particular pod needs to get scheduled. So once API server will get this information from scheduler, then it will interact with kubelet and it will make a request that you have to bring that pod up in your worker node. Then kubelet will bring up the pod in that particular worker node, whatever the pod specifications were there, and it will maintain the state and it will keep on checking and it will keep on sending the information about the pod status, its state, and everything. So this is how it works on the cluster. In this video, we covered what, why, and how part of Kubernetes. I hope this will really help you in building the strong foundation in Kubernetes. In the future video, we will do some hands-on by installing Kubernetes in our local environment and then creating an app, deploying the app, and monitoring the app, and other aspects of Kubernetes. Thank you so much for listening to me and have a great day. I'm signing off. See you in the next video.